Welcome to Across the Globe. Today we will learn about logistic regression basics. Logistic regression is a statistical method employed in predicting the outcome of a categorical dependent variable by utilizing one or more independent variables. Commonly utilized in binary classification scenarios where the result encompasses only two classes, logistic regression aids in estimating the probability of an outcome occurring. For example, in predicting whether a customer will default on a loan based on factors such as income, credit score, and debt-to-income ratio, logistic regression can be employed to ascertain the likelihood of default occurring. Logistic regression outputs a probability score indicating the likelihood of a data point belonging to a specific class. This is achieved by applying the sigmoid function to the linear combination of input features, producing a probability value between 0 and 1. The process of estimating the model parameters in logistic regression is carried out through maximum likelihood estimation, helping to determine the optimal fit for predicting class probabilities based on the input data. For instance, in a binary classification scenario like predicting whether an email is spam or not, logistic regression can output a probability score indicating the likelihood of an email being spam based on its features. Logistic regression is a statistical method used for binary classification tasks. In this case, we can predict whether a student will pass or fail a test based on their exam scores. The logistic regression model estimates the probability of an event occurring, passing the test, based on one or more predictor variables' exam scores. In the provided Python example using scikit-learn, the code sets up a logistic regression model with exam scores as the input features, x, and pass-fail labels as the output, y. The model is trained on the given data using the fit method. After training, the model can make predictions on new data points, such as predicting whether a student with an exam score of 85 will pass or fail the test. In real-world scenarios, logistic regression can be applied in various fields, such as predicting customer churn in a telecom company based on usage patterns, determining whether a patient is likely to have a particular disease based on medical test results, identifying fraudulent financial transactions based on transaction history. By understanding and implementing logistic regression, practitioners can accurately predict binary outcomes based on input features, making it a valuable tool for classification problems across different industries. Logistic regression is a machine learning algorithm utilized for binary classification tasks. It predicts the probability of the outcome using the logistic function. The model parameters are estimated via maximum likelihood estimation, enabling the algorithm to predict outcomes for new data points. For instance, in an e-commerce scenario, logistic regression can be employed to predict whether a customer will purchase a product based on factors like demographics and past behavior, aiding in targeted marketing strategies. Logistic regression is like a chef trying to predict if a dish will be salty or not based on the ingredients used. The chef looks at each ingredient input variable and assigns a weight coefficient to it based on how much it affects the saltiness of the dish. To make the prediction, the chef adds up the weighted ingredients and applies a logistic function to convert it into a probability of the dish being salty. This prediction can then be converted into a program where the input variables are the ingredients and their weights, and the logistic function is applied to generate the probability output. Hey, code conquerors, ready to level up? With TechLearn ATG, showcase your skills with official course certificates. Just visit our site and start. Need that extra boost? Get tailored learning, 24/7 support, and expert guidance. Coding smarter, growing faster, and making learning fun. Go to our website across the globe, www.atg.world. Logistic regression is a fundamental tool in machine learning for binary classification tasks where the output is a probability value between 0 and 1. In the provided code snippet, the sigmoid function is implemented to model the logistic function. This function helps in converting the linear combination of inputs into a range of probabilities between 0 and 1. The logistic regression class is established to handle the prediction task. It takes in the weights associated with the input features and uses them to calculate the dot product of inputs and weights. The obtained value is then passed through the sigmoid function to get the probability of the output being in a particular class, in this case, the probability of the dish being salty. For a real-world application, consider a scenario where a food delivery platform wants to predict whether a newly added dish is likely to be classified as salty, based on its ingredients. By employing logistic regression with ingredient weights decided by expert chefs, the platform can provide personalized recommendations to customers who prefer salty dishes, enhancing their overall dining experience. One industrial application of logistic regression basics is in the field of marketing. Companies often use logistic regression to predict the likelihood of a customer purchasing a product based on various features such as demographics, past purchase behavior, and website interactions. By analyzing these factors and assigning appropriate weights, businesses can optimize their marketing strategies to target customers more effectively. Another real-world example is in healthcare for predicting the risk of diseases. By utilizing logistic regression on medical data such as patient symptoms, lab results, and lifestyle factors, healthcare providers can estimate the probability of a patient developing a certain condition like diabetes or heart disease. This information can then be used to implement preventive measures and personalized treatment plans. Across the globe, logistic regression plays a crucial role in diverse industries by providing valuable insights and predictions based on input variables and weights, ultimately aiding decision-making processes and improving outcomes. Keep learning, stay curious, and I'll catch you in the next video.